let's see if we can extend our thinking about radicals. Let's start with something that's familiar, question A. Notice in this situation, each of the radicals that are listed are square roots. That means we are looking for a number that multiplied by itself twice in order to give the radicand, or what is inside the root sign. So these are the traditional types of roots that we've looked at in the past. Notice in this situation, we might need to simplify the radical. That is, if the number inside the radical, the radicand, is bigger than it has to be. And notice we're also adding and subtracting radicals, so this will bring a couple of ideas into play. So let's start with the root 12, simply because it looks like that could be simplified a little bit more. You'll recall that when we're trying to simplify radicals, we try to rewrite what's inside the radical as a product of two numbers, one of which would be a perfect square here. Perfect square because we are dealing with square roots. So we have a little root index. We don't write this in, but nonetheless it is there even though we don't write it in. So let's talk about what we mean by perfect squares. So numbers that are obtained by multiplying the number by itself. So 1 is the same thing as 1 squared. 4 is the same thing as 2 squared. I would also have 9, 16, 25, 36, 49, and so on. Those are perfect squares. So when I am looking to try to rewrite each radical as a product of two other numbers, I want those numbers to be perfect squares. So we notice that root 12 could be written as root 6 times root 2, but neither the 6 or the 2 are perfect squares, so we're not going to select those numbers. Instead, I also noticed that root 12 could be written as root 4 times root 3. Since 4 is a perfect square, I'm going to use that number. So I'm going to rewrite that as root 4 times root 3. And the square root of 3, I can't simplify that anymore. And the same thing with the square root of 2, so I'll leave that as it is. Let's go forward from here, taking a look at our first radical. Square root of 4, we can replace that with 2, so we end up with 2 root 3 minus root 3 plus 2 root 2. We notice that we now are needing to deal with the addition-subtraction. We said addition and subtraction of radicals was much like dealing with algebra, meaning that only the radicals that had the same radicand, or number inside the root, could be put together. One of the things we need to recognize is that there is a coefficient of 1 in front of that root 3. If nothing is written there, we are assumed there is one of those. So trying to group our like radicals together, we notice that these both have root 3's. This one has a root 2, so I'm not going to be able to put that together with the other two radicals. So I have 2 root 3 minus root 3, which is going to leave me with 1 root 3. I could have just left that as root 3 without the 1 in front. That would have been okay, plus 2 root 2. So that would be finished. I would not be able to proceed any further. I want you to notice the next question looks a little bit different. So these types of questions that were on the bottom of the page that I asked you to extend your thinking on are really ones where you're using thinking and inquiry and trying to extend the ideas that we learned about radicals and really use our mathematical processes and critical thinking skills. So I say that in that it's asking you to extend your thinking. We will definitely come back in about 2 weeks and look at these in a lot greater depth. And in that time, we are going to go through some detailed lessons about how to do this. Nonetheless, I want to help you get going with this so that you can try to really challenge yourself with these questions. So what you're going to notice here is that instead of having square roots, we have cubed roots and we have a sixth root. When we're dealing with something like a cubed root, when we want to evaluate that, instead of asking ourselves what number multiplied by itself twice gives us what's inside, we're instead asking what number multiplies by itself 3 times to give us what's inside our radical. So if we are going to try to simplify cubed roots instead of simplifying square roots, we need to think about numbers that are perfect cubes instead of perfect squares. So let's look at what those could be. So if I had 1 cubed, that's 1. If I had 2 cubed, that's 2 times 2 is 4 times 2 is 8. 3 cubed is going to be 3 times 3 is 9 times 3 is 27. 4 cubed is going to be 4 times 4, 16 times 4 is 64. Let's do one more. 5 cubed is 5 times 5 is 25 times 5 is 125. So I could extend and write down more cubes, perfect cubes if I wanted to, but hopefully that will help us here. So if I want to simplify these cube roots, I'm going to do it in much the same way as I simplified square roots. So let's take a look at the cubed root of 27. I notice that that's actually something that I can just evaluate right away. Notice that if I am trying to evaluate this, I'm asking myself what number multiplies by itself 3 times to give me the radicand, in this case 27, and just by writing out our perfect cubes, we see that that answer would be 3. Let's take a look at the next one. Cubed root of 54. I'm noticing here in my list of perfect cubes that 54 is not among them. So I am definitely going to need to have to try to factor the 54 in some way. When I am trying to factor the cubed root of 54, I am looking to use two numbers, one of which is a perfect cube this time. So I'm asking myself whether or not any of these numbers that are perfect cubes divide evenly into the number 54. What I'm hoping you'll see is that 54 is actually equivalent to 27 times 2, so I could rewrite this as cubed root of 27 times the cubed root of 2. I'm going to go out to the last term now. I've got the 6th root of 7. Wow. So my question that I'm asking myself here is there a number that when multiplied by itself 6 times is going to give me 7? So I would need to look at, instead of raising values to the exponent 3, I would need to consider raising them to the exponent 6 and creating a whole new list. What I can see, though, is that looking at these numbers over here, I can see that I'm never going to get some number multiplied by itself 6 times to give me 7. So I'm not going to be able to do anything else with that number. I do not want to start using decimals and the like, so I'm just going to leave that and know that I'm not going to be able to simplify that anymore. Let's do one more line here. I'm going to copy down the 3. I'm going to copy down the 6th root of 7. And now I'm going to try to simplify these cubed roots. So the cubed root of 27 is going to give me 3, just like it did before, and I'm going to be left with the cubed root of 2. Now, I'm always looking to see whether or not I can group like terms and simplify them. I notice here that I've got just a 3, I've got a cubed root of 2, and a 6th root of 7. There is nothing that is alike there. If I had another sort of 6th root of 7 somewhere, then I could group it with this one. If I had another cubed root of 2 somewhere, I could group it together with this term, but I don't. So I am really finished here. What I want you to take away from this little mini lesson is just some extended thinking. I don't want you to spend tons and tons of time looking at this because, as I said, we will be revisiting this in a little bit. So even though this is extension, this is really application and thinking outside the box, let's give this next one a try. This was one of those extended thinking questions that I asked you to practice. So let's take a look at question number 8. You'll notice in this scenario that we are looking at the 6th roots of each of these numbers. To help us with this thinking, I've actually written down some numbers to the exponent 6, some powers with exponent 6. I stopped here at 729 once it got really big because these numbers in here are smaller than 729, so I know clearly 729 would not be a factor of any of the numbers that are listed there. So I didn't really need to proceed any further. I would like to see whether or not I can take any of these larger numbers and rewrite them as products of any of these to the exponent 6 powers. So let's take a look at this first one. Negative 3 times the 6th root of 3. So this 3, clearly I'm not going to be able to do anything with that. any of these numbers here cannot be used to write 3 as a product of it and itself. So I'm just going to copy that down, the 6th root of 3. Let's take a look now at the 6th root of 192. So we established that 729 is going to be too big. Let's see if I can go 192 divided by 64. That is equal to 3. So that's possible. I can actually take the 6th root of 192 and rewrite it as another product. So I can rewrite that as a product of the 6th root of 64 and the 6th root of 3. Let's take a look at the 320 now. Can I take 320 and divide by 64? I check with my calculator and I find that I can. That answer is 5. So I can rewrite the 6th root of 320 as the 6th root of 64 times the 6th root of 5. Now I can go ahead and try to simplify a little bit more. I'm going to copy down the first part of the question, and now I'm going to evaluate the parts of the second and third terms that I can. So notice the 6th root of 64, this is something I can actually evaluate and use to simplify the expression. So I'm going to copy down the 2. The 6th root of 64 we know is equal to 2, because we're asking ourselves what number multiplied by itself 6 times gives us 64. If I think about 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64. If I'm counting on my fingers, that's 6 2's I've multiplied together. I'm going to copy down the 6th root of 3, and then again the 6th root of 64 is 2, and I'm going to copy down the 6th root of 5. Let's see if we can simplify a little bit more. 6th root of 3 minus 4, 6th root of 3 minus 2, the 6th root of 5. Now that we've gotten to this point, we would like to try to group our terms if we can. I noticed that the first 2 terms actually have the 6th root of 3. They have the same radical, so I can group those together. This last term has the 6th root of 5, so it's not going to be able to go together with the other 2 terms. So I have negative 3, 6th root of 3 minus 4, 6th root of 3, so I'm going to have negative 7, 6th root of 3 minus 2, 6th root of 5. So from here you can give some of these other questions a try. Remember, it is extending your thinking, so don't be too hard on yourself if you're having difficulty with this. We will be checking back in with it later.